Evolution has become a popular concept in media with franchises like Pokemon, for example. And if you want to spice things up, All Tomorrows, Man After Man, The Future is Wild. But to know about those, you need to have a very good social life and loads of sex. I am not a weird one. In this video, we are going to explore how evolution works in a real-life scenario and try to explain how small turtle becomes slightly bigger turtle and then a war crime. So let's have a look. Across history, multiple theories for how evolution works were developed, but in this video we are just going to talk about the three main ones, starting of course with Lamarckism. This was always a very funny one to me. It was proposed by John Baptist Lamarck in 1809, and it was based on the principle of inheritance of acquired characteristics. Now, how the animals acquire those characteristics is where the fun begins.
This is where the fun begins.
Basically, according to Lamarck, animals would evolve based on necessity. For example, imagine this. Oh no, I'm so hungry and there is no food here close to the ground. But wait, look there. In the trees, yummy yummy leaves. And that is how they acquired those characteristics. I made it way more simple for comedic effect, but that's the concept. They would evolve based on necessity and later pass those new acquired characteristics to the next generation through mating. In terms of evolution, this is the closest one we see in Pokemon, you know? If you pay close attention, like, it starts as a turtle, for example, and then it becomes a war crime with cannons. A lot of Pokemons develop characteristics specifically designed for fighting because they are used to fight, so they evolve characteristics that helps them fight. However, I think in Pokemon, evolution is not the term I would use. I use probably metamorphosis. You know, that's a very funny thought experiment. I might make a video about it. And this is how I have ideas for my videos. You saw it happen live. Think how lucky you are. Darwinism. Later, a man called Charles Darwin proposed another theory for evolution. At the start, included broad concepts of transmutation of species and a term we are very familiarized with today, natural selection. This gained general scientific acceptance after he published his book On the Origin of Species in 1859, a long-ass time ago. Later, Darwinism became Neo-Darwinism, after getting combined with Weismannism, proposed by August Weismann. What's the thing with the last name thing they do? Weismannism is not really relevant for the video, but basically it refers to the idea that heritable information can only be passed through individuals by the germ cells in the gonads, basically ovaries and testes, reproductive cells basically, and not somatic cells, skin for example. This Neo-Darwinism falls more in line with what we understand today about evolution. It is actually, at time of recording, the current theory for evolution. And it goes basically like this. Hello, I'm a giraffe and I have a very small neck. Hello, I am also a giraffe, but I was born with this slight random mutation that made my neck slightly longer. Oh no, you died as I was speaking because you can't reach the leaves up here, so you starved. Oh no. Now I get to procreate and have more long-necked babies because my mutation appears to be favorable to my survival and the future of my species. Eventually, between 10,000 and 10,000 million years, we will have giraffes that resemble the ones we have today. And that's basically what Neo-Darwinism tells us about evolution. It all starts with a random genetic mutation that later proves to be favorable to the survival of that individual. It starts with one individual and later gets passed to the next generation. So the ones that have the favorable genetics survive and the ones that doesn't die. That's natural selection. But now you ask, if evolution is random, how do you justify so many animals have the same body plan?
In my experience, there's no such thing as luck.
And to that, we have to talk about convergent evolution. Animals live together in habitats and follow different rules. Those rules are called ecological niches. Basically, an ecological niche is the relations an animal establishes with its surroundings, basically what it eats and what eats it. So convergent evolution is a phenomenon that happens in nature where different animals that inhabit the same or very similar ecological niches adopt very similar body plans because that's simply what works best for the job. A great example of this is the shark, the dolphin, and the ichthyosaurs. One is a fish, the other is a mammal, and the other is a reptile. They have no common ancestor, but they all look very similar because they inhabit the same ecological niche. When an animal dies and leaves their ecological niche empty, that's a source of food and energy no one is going after. With the excess of food and without any competition, nature takes its course. Here's an hypothetical example. A lizard is born with this random genetic mutation, a very thin, long skin that unites his front legs to his hind legs. Poor lizard can't even move properly. He will probably die. What a shame. Anyway, on another hand, a virus is killing all the aquatic birds in the area. Oh no, very bad news if you are an aquatic bird because you went extinct. But probably very good news if you're a weird lizard. You see, this weird lizard starts eating all the small fish and all of the small amphibians like frogs in the rivers and ponds in the area because no bigger predators are around to stop him from doing so. And now that he has a more reliable source of food and energy, he is more likely to mate and produce more weird lizards. And over time, from hundreds to hundreds of million years in the future, random genetic mutations can take place. Shorter hind legs, longer front legs, longer snout, and look at it! Doesn't he look very similar to those old birds that used to live here? And this is how evolution in convergent evolution works in very broad and easy to digest terms. And this was the video. I know evolution is a weird subject to make an entire video around, but I thought it could be funny to make a video about evolution in a more chill and casual way. Science is a very fun topic to simply have a conversation about. I hope you liked it. See you next time.